Hello everybody. In today's session we're going to talk about the differences between linear regression and multiple linear regression. They are essentially the same. So far we've spoken about linear regressions that uses one continuous variable as a dependent variable and a continuous, ordinal or nominal variable as your independent variable. What we've also done is we've talked about throwing a categorical variable in. So like on that image on your left, what you can see is the difference between two groups. So let's say male and female. Quite simple. And that's very one-dimensional if you visualize it. The big difference between simple linear regression and multiple linear regression is that multiple linear regression is multidimensional. As you can see from the image on the right, we are now talking about having more axes if we visualize in data. Obviously, we can't visualize data in more than 3 dimensions. But in a multiple linear regression, we can have lots and lots of levels. So we could have 6, 7, 10, 16 various different multiple independent variables. So that really is the biggest difference. So we are starting to be able to predict our dependent variables using lots of different variables. So we could have gender, we could have income, we could have political leaning, whatever that might be, we can throw lots of different variables into a multilinear regression. Just as a reminder, here's the equation we used for simple linear regression, where we have the slope and the intercept and the independent variable that predicts the dependent variable. And multilinear regression looks a lot more scary, but actually isn't, because all we are doing is we are adding in another independent variable with its predictor and its slope, as well as an error term in the end. Looks scary. Like I say, you don't have to worry about it too much. The computer does that for you. Here are some really key points for linear regression, whether that be simple linear regression or multiple linear regression. Your dependent variable requires a continuous variable. You should always use a continuous variable as your dependent variable. There's some exceptions, I'll talk about that in a minute. If you have got an ordinal or a binary variable as your dependent variable, then there are other methods such as logistic regression, but we are not covering that in this course. The independent variables can be continuous, ordinal and nominal. Again, whether you have simple or multiple linear regression, you can throw lots of variables in. Don't throw variables in that are not really related. So as you're putting a variable into your model, make sure you think about why are you including it? What's your rationale for having that included? When you're running a model, if a variable comes back as non-significant, remove that from your model, unless you are specifically interested in that variable, and then you can report a negative effect, so saying actually there is no correlation. Like I said, there are some exceptions to the dependent variable being a continuous variable. Sometimes you can use an ordinal variable. If that is the case, it should have a scale of at least 5. The higher the better. You should have some rationale for treating it as an ordinal, as a continuous variable, because you are making a certain assumptions, and the assumption is that the distance between each point is the same. Sometimes that's okay, other times that's not. Get to know your data, and then you'll be able to make that decision. Just remember, if you put rubbish into your model, you'll get rubbish out. So at the end of this session, you will be able to understand the difference between simple linear regressions and multiple regressions and how to use them.